So welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is digital twin and blockchains. This is also part of the main playlist of digitalization. So let's move on to the main content of this presentation. So let me elaborate why this is an important concept. These digital networks, for example, this digital twin for systems or digital twin for systems of systems and blockchains for various industrial processes can share the same framework. Therefore, these networks or these digital networks can complement each other under various applications. You should also note that when these applications being shared throughout the network, that can be considered as a distributed intelligence. So let's talk about the evolution of digital networks. So there are various digital networks have been utilized under extreme data for various industrial applications. These applications can be categorized into two groups of systems and processes. So if you have a system or a system of systems type of application, then digital twin type of framework can be more utilized, more suitable for your application. But if you have a industrial processes, then blockchain type of application would be more suitable for your process. And both the systems and processes are based on extreme data. Therefore, these two types of digital networks can complement each other. So let's try to define what is a digital network. So a digital network can be defined as a group of nodes that are connected in a predefined distribution. So these distributions can be series, parallel, or combination of both. And of course, these networks probably related to industrial application of either system or a process. And then these nodes can be categorized as a data or the information clusters. I think we have discussed this type of clusters or the data clusters in the digital twin development process also. And there should be a strategy to guide how these nodes should interact with each other. So that strategy eventually control the behavior of these digital networks. And then I think we discussed the evolution of digital twin in a separate video, and then I would place the link to that video also in the description of this video. Therefore, you can go through this development of a digital twin. As just a summary of that development, I would say this digital twin was based on this data or the information clusters. Eventually, these clusters create these superclusters, and then the superclusters, the combination of superclusters eventually create this system of system data space. So that is how we have developed that digital twin framework from starting from a single cluster and then moving towards system of system data space. So similarly, we're going to use a similar type of strategy towards the digital networks, especially under the blockchain technologies. So let's elaborate this digital network of blockchains further. So here I am not trying to enforce that blockchain may be the only digital network that you can implement it in various industrial processes, but blockchain can be an example of such type of digital network that can be implemented in some industrial processes based on the requirement. So let's try to define this concept of what is a blockchain. So a blockchain represent a decentralized, distributed digital ledger systems, which is in a public domain, and that can handle and record transaction executed by many users. So that consists of a decentralized transaction process due to the same reason, and there are additional data management technologies should also be facilitated towards these digital networks. So the bitcoins or various cryptocurrencies can be examples of this type of digital networks. And then if you try to look into the development of a blockchain, that would start from the first block, which is called this Genesis block, and that represents the first block or the birth of a blockchain. So rest of the blocks or the nodes would be built upon this genesis block. So the main blockchain consists of honest nodes of the network, which is represented in this figure in blue boxes. So those nodes are identical blocks with transactional information that are shared and stored in the main chain. And it is expected that this chain should have adequate system intelligence and the power to control the entire network. So let's try to derive some similarities between the digital twin and blockchain type of technologies. So the honest node in the main chain in these blockchains are somewhat similar to the normal data clusters that we have discussed under the digital twin. So you can see the main concept of these honest node or the normal data clusters are somewhat a similar concept shared between these two digital networks. So let's try to understand these blockchains a little bit deeper in this situation. So the main chain of this type of digital networks, there are additional blocks being attached. So these blocks are categorized as orphan blocks. So the orphan blocks can be categorized as a not so honest node that may not be a part of the main chain. And these blocks can be created due to the time delay in the network or by cyber attacks that could interfere with the respective transactions. So often these blocks can be categorized as invalid blocks but attached to the or related to the main chain. And then if you're trying to see a relationship between this digital twin and the blockchains with respect to these orphan blocks, so these not so honest blocks are somewhat similar to the data anomaly clusters that we have discussed under digital twin. Again, you can see these fundamental concept being shared between both of these digital networks. So let me conclude this presentation by introducing some common features in these digital networks of digital twin and blockchain technologies. So these networks can accommodate several features. The first one is self-learning. That means these networks can learn itself. So both honest node as well as the normal data clusters can be identified by these networks themselves. So that is the process of self-learning. So the second feature is self-cleaning. That means the not so honest node as well as data anomaly clusters can be identified these networks itself, as well as they can isolate or they can recover by themselves. And the third feature is self-compression and expansion. Obviously, these networks can expand themselves due to the operational requirement, as well as they can compress themselves to reduce the respective dimensionality. And finally, self-visualization. So the information stored by these digital networks can be visualized to the users as in a more user-friendly way. So that way that information can be utilized towards making smart decisions. So that was the main reason we developed this type of digital networks on top of the extreme data that you are collected either from a system or a process in these various applications. So that's the end of this presentation. Hopefully you have enjoyed that. So if you are still interested, please stick around. Thank you.